Morning, students. Today I am going to take up asymptotes. What's an asymptote? Let me consider an example. Y equal 1 upon 1 minus x. This is the curve actually. 1 minus x into y equals 1. Okay? Sorry, yes. Or y minus xy minus 1 is equal to 0. Now, if I would like to have a graph of this curve, what will be the graph of this curve? You see, first of all, you can see that when x is 1, when x is y is infinity. So let me take up x equal to 1. This is 0, this is 1, and let this be the line x equal to 1. This is the line x equal to 1. Now let me draw the graph. See, when x is 0, your y is 1, means this point. When x is half, 1 minus 1 by half, so y is 2. And so on. When you will go here, you will reach here. Okay. Similarly, so if I will draw a graph of this curve, this will be like this. And you see, this line may touch this curve somewhere at infinity. When x is 1, when we will reach towards 1, this y will go towards infinity. Obvious? When x is 1, y is infinity. So when x is 1, from this to this point, we'll go from this point to this point to this point to this point, this point. Ultimately, when we reach x equal to 1, this curve goes to infinity. So one can see that if I have this distance, this is the point on the curve. Let me suppose that this is the point on the curve. When this point moves along the curve towards the infinity, you see, this distance becomes more less, or more less, and less, and less. Ultimately, it may touch to the curve at infinity. So the line which intends to touch the curve at infinity is known as the asymptote. This is the asymptote. So generally, an asymptote is a line which may touch the curve at infinity, right? So this perpendicular distance becomes much less and less, This from this line, as the point recedes towards infinity, the perpendicular distance becomes less and less and less. Ultimately, may touch to the curve at infinity. So the line is known as the asymptote. Similarly, from here, you may have this may touch somewhere here. This will be the asymptote. Okay, you can see that if we take points beyond 1, because you can approach a point. If x approaches 1, you can approach a point from left as well as from right. You will see that this will be the curve. So this is the asymptote. You can see this distance, perpendicular distance, tends to 0 ultimately. So the line, this is the line, x equal to 1 is known as asymptote to the curve at infinity, right? So this is the definition. So you have seen that how are the curves look like. How do curves look like? Now, let me define what is an algebraic curve. Algebraic curve. An equation of algebraic curve is usually represented in this form. You can see the book an x raised power n, an minus 1, x raised power n minus 1 y, plus so on, y raised power n. say b a n minus 1 a n minus say a0, doesn't matter, whatever you write, a constant times yn. These are all terms having the degree n. Then the terms containing the degree n minus 1, say bn x raised power n minus 1, bn minus 1 x raised power n minus 1 y, say b0 y raised power n minus 1, plus so on, say lx plus my plus constant equals 0. This is known as equation of an algebraic curve. For example, if we have a linear curve x plus y, say x plus y equal to 0, this is an equation of an algebraic curve of degree 1. This is another degree, okay? Now, if I will add x square plus y square plus 2xy. Now, this is an algebraic equation whose degree is 2. Whether this factor is there or not, still degree is 2. This factor is not there, this factor may not be there, but then degree is 2. As soon as there is a term of degree 2. You can have it as a cubic, say x cube plus y cube, then you must be having, say, x cube y, x square y, xy square, and no other term in terms of x and y. Algebraic curve in terms of x and y. So this is a cubic. This is a cubic if only you have finite number of terms. Say you have x cube and these are terms. You have x cube and this factor only, not this factor. You have x cube, no other factor, equal to 0. So these kind of equations are known as algebraic equations. You can see from this plus some constant, you can always write. If there is no constant, doesn't matter, but then it does contain a constant also. Say x plus y plus 5 equal to 0. Obviously, you know y equal mx plus c is equation of a straight line, right? Y equal mx plus c. This is y equal mx plus c. Y equal, say, x plus 5 or minus x minus 5. This is of this type. Y equal mx plus c. Your slope is 1, m is 1, minus 1, and c is minus 5, right? So equation of line we write usually as in this form. So one can observe that if you take y from this or x from this will be 1 plus y by x, right? If you take x square from this, you will get 1 plus y by x square or y square by x square, 2y by x. If you take x cube from this will be 1 plus y cube by x cube, then y by x, then y square by x square. Okay, you are dividing by x cube, so y square by x square, because you are dividing by x cube, now x will cancel out, equals 0, or plus k, doesn't matter, or k by x square, or equal right hand side equal minus k by x cube, doesn't matter. What I am interested in is this, in this form. This is x some function of y by x, or let me write in this form. X, this is function of y by x. Okay, this is x square, this is some function of y by x. This is x cube, some function of y by x. This is, say, function 1, this is function 2, and this is function 3. Obviously, its degree is 1, degree 2, and degree 3. That is why I have kept some different. Say you have phi, psi, and so on. Because I will be using these notations in my future lecture, so I am explaining this. So this equation can be written in this form also, because if you take x raised power n from this, you can write this equation in this form also. X raised power n, this equation, you may write this in this form. X raised power n, some function of y by x. but its degree will be, see, its degree will be 3, its degree is 2, its degree is 1, so its degree will be n, right? Because every term is of degree n. Then x raised power n minus 1, some function of y by x again, but its degree will be n minus 1. Each degree is of degree n minus 1. This was of 3, this was of degree 2, this was of degree 1, and so on. Finally, you may have a function of degree 1, some constant also, or equal to some right hand side, or no constant, it is equal to 0, doesn't matter. So we can write in this form. Now, in order to find the asymptotes, what do we see? You can have you have the Asymptotes book, article is there. We put y equal mx. Let us suppose that y is mx plus c be the asymptote. This is the straight line. We have to see that this touches the curve somewhere at infinity, or it may or may not touch. By the way, nth degree equation may have n asymptotes. It may have or it may not have. For example, we have circle x square plus y square equal a square or r square. It's a circle. It doesn't have an infinite branch of a curve. Although it is of degree 2, it doesn't have an asymptote. But usually an nth degree equation has n asymptotes or may have n asymptotes. So how do we proceed for finding the asymptotes? We have to find only two things: m, the slope, and this intercept c. These two are known to us. We can find the asymptotes. Okay. Now, what is the method of finding asymptotes? I will be just letting you know about that. Okay, let me keep it like this. You see, you have an nth degree equation. You have an nth degree equation. This is nth degree equation. This was nth degree equation. If you have nth degree equation, first of all, you have a curve. There will be some equation of that curve, algebraic equation of that curve, as I have told you. So let me suppose that we have an nth degree equation. Now, what is the rule? What is the thumb rule? How to find the equation? First of all, let me tell you, there may be two kinds of asymptotes. I have shown you. Maybe this is the curve. You can have parallel asymptotes, parallel to y-axis, parallel to x-axis, right? Or there's a line, this is parallel to y-axis. There's a line, this is parallel to x-axis. Okay. So you may have asymptotes, parallel asymptotes, or oblique asymptotes. Oblique are those which are not parallel. Say you have this kind of thing over here. You have these straight lines are there. These are neither parallel to x-axis nor parallel to y-axis. These type of asymptotes are known as oblique asymptotes, right? Now, what's the rule? Thumb rule is that if we have nth degree equation, if in nth degree equation highest power x raised power n and y raised power n are present, then there will be no parallel asymptotes. If it is a cubic, you have x cube and y cube present, then there are no asymptotes parallel to either axis. But then, if x cube and y cube are absent, then the next powers of y and x, for example, you have x cube is not there, but x square is there, then power of that term when equated to 0 gives us asymptote parallel to x-axis. Similarly, power of y square when equated to 0 gives us asymptote parallel to y-axis. Now, you may not have x square there or y square there. Then you have to go to the next quotient. What is the x square? After x square, it's quotient of x. If quotient of x when equated to 0 gives us asymptote parallel to x-axis. Similarly, quotient of y when equated to 0 gives us an asymptote parallel to y-axis, provided those are not constant. The coefficients are not constant. You cannot have constant equal to 0. Say you have 5x, you cannot take 5 equal to 0. Okay? Okay, fine. So let me take up the questions. Okay? Let me explain you again. If you have an nth degree equation in which x raised power n and y raised power n are present, then there are no asymptotes parallel to either axis. But then if they are absent, then the coefficient of next higher power of x and y gives us, when equated to 0, gives us asymptotes parallel to x-axis and y-axis. Okay, let me take up the question. For example, say you have x square y plus xy square equal a times x square plus y square. See, this is an algebraic curve. This can be written as x square y plus xy square minus ax square minus ay square equals 0. This is a cubic in x and y. This is a cubic in x and y, wherein x cube and y cube are absent. See, this is a cubic in x and y, wherein x cube and y cube are absent. So there may be asymptotes parallel to x-axis and y-axis, which are equated, as I have said, which are obtained by equating coefficient of next higher powers of x to 0 and next higher power of y to 0. But then, if this is again a cubic, if I will write x cube plus y cube plus this thing, x cube plus y cube plus this thing, then since x cube and y cube are present, there will be no asymptotes parallel to either axis. Okay, this is the first rule. If x cube and this is a cubic, while x cube and y cube are present, so no asymptotes parallel to either axis. But if x cube and y cube are absent, just I have taken this question, x cube and y cube are present, so we may have asymptotes parallel to either axis. Now, I will write down the way you have to write it in examinations also. This is a cubic in x and y, wherein x cube and y cube are absent. So there may be asymptotes parallel to either axis. Either axis means x-axis as well as y-axis. Now, which are obtained? How they are obtained? Which are obtained by equating coefficients of next higher powers of x and y to 0. Now, which is the coefficient of next higher power of x? Means coefficient of, here you have x square. X square is there. Now, coefficient of x square equal to 0 implies, we see, you have x square, y square here, and you have minus ax square equal to here. Then what is the coefficient of x square? It is y minus a equal into x square equals 0. So I have to equate coefficient of x square to 0. That means y minus a x square equals 0. Coefficient of x square equals 0 means y minus a equal to 0. You need not write this because you need to write only coefficient. Coefficient of x square is y minus a equals 0 means y equal a, which is an asymptote parallel to x-axis. X cube is absent, so you have to take coefficient of x square. Then equating coefficient of x square to 0, you will get asymptote parallel to x-axis, right? If x square would not have been there, then I have to go to coefficient of x. This is the way, provided this coefficient is not constant. Similarly, coefficient of y square, you can see y equal a. This is x equal something, this is y equal a. Say this is a. Now let me draw a line. Y equal a is this line. This is an asymptote parallel to x-axis. This is x-axis. X-axis, y-axis. See, y equal a is an asymptote parallel to x-axis. Now, coefficient of y square equal to 0. See y square. You have y square over here, y square over here. What is the coefficient? X minus a equal to 0 implies x minus a means x equal a, which is an asymptote parallel to y-axis. See, x equal a. Say this is a. Say x equal y equal to 1, x equal to 1. This is an asymptote parallel to y-axis. Fine. Again, if y square was not there, then I have to go to coefficient of y. Now let me take up next question. See, this is a cubic. I have said that an nth degree equation may have n asymptotes. You have one parallel asymptote to x-axis, one asymptote to y-axis. There may be third asymptote also, which may be oblique. I have not said anything about oblique till now, so I will not be discussing that. I will be discussing only parallel right now. Let me take up the question. Y cube minus x square y minus x square minus 1 equal to 0. So this is the question. Y cube minus x square y minus x square minus 1 equals 0. See, this is a cubic in x and y. Cubic in x and y. X and y. Wherein y cube is present. So no asymptote parallel to y-axis. I am just finding y-axis, parallel asymptotes only. So no asymptote parallel to y-axis because y cube is present. Now, x cube is absent. So there may be asymptotes parallel to x-axis, right? Because x cube is absent. So there may be or there may not be. So there may be asymptotes parallel to x-axis, which are obtained how? Which are obtained by equating coefficient of next higher powers of x to 0. By equating coefficient of x square to 0. Now what is coefficient of x square? You have x square over here, you have x square over here. So it is minus x square y minus x square means minus x square times y plus 1. This is the, so coefficient of x square is y plus 1. So equating coefficient of next higher powers of x to 0 is y plus 1 equal to 0. Means y equal to minus 1. Which is an asymptote parallel to x-axis. See, y equal to minus 1. Minus 1. So this is an asymptote parallel to x-axis. Right? This is the way how do we find the parallel asymptotes. Now let me take one more question. Say you have x square y square minus x square y minus xy square plus x plus y equal to 0. X square y square minus x square y minus xy square plus x plus y equal to 0. This is, see, now I will not write much. This is a fourth degree equation. This is a fourth degree equation in x and y, while in x4 and y4 are absent. So there may be asymptotes parallel to either axis, which are obtained by equating coefficient of x cube next higher power. After 4, what is the next higher power? It is cube. X cube and y cube to 0. But there are no x cube and y cubes. So I have to just jump to the coefficient of x square and y square to 0, which are both present. So I will write, this is the fourth degree equation x and y. So no asymptote parallel to x and y, and x4 and y4 are present. So no asymptotes parallel to, asymptotes, there will be asymptotes parallel to either axis, which are obtained by equating coefficients of x cube next higher power and y cube to 0. Since x cube and y cube are also not present, so equate coefficient of x square and y square to 0. This is very simple. Now coefficient of x square equal to 0 implies what? What is the coefficient of x square? See, if here x square is here, x square is here. What is the coefficient? Coefficient is y square minus y equal to 0. Means y into y minus 1 equal to 0. Means y equal to 0 and 1. Two asymptotes parallel to y equal to 0 means x-axis, which is an asymptote parallel to x-axis, right? And y equal to 1 is an asymptote parallel to x-axis. Now, coefficient of y square equal to 0, y square. Here it is y square, here is y square. So what is that? X square minus x equal to 0. So x into x minus 1 equals 0. So x is 0 and 1. So these are the asymptotes parallel to y-axis. X equal to 0 means y-axis. So y-axis is parallel to y-axis. So this is one parallel asymptote, and x equal to 1 is an asymptote parallel to y-axis. This was 4th degree. You have two asymptotes parallel to x-axis and two parallel to y-axis. There will be no oblique asymptotes. Let me take one more question, or let us go to oblique asymptotes. Now, how to find oblique asymptotes? I will let you know the rule, and we will be doing a few exercise. Oblique asymptotes. See, what is the rule? You have an algebraic equation. We put, let me suppose that y equal mx plus c is an oblique asymptote. Let me suppose that y equal mx plus c is an asymptote. What type of asymptote? I don't know. It may be parallel also, it may be oblique also. So I have to find two things, this slope m and this intercept c. What I will write? You have algebraic equation. What is the algebraic equation? It is, I will write the rule only. Rule, what is the rule? First, step 1, or let me write down, because you don't know. See, algebraic equation, how do we write algebraic equation? X raised power n, phi n y by x. This I have just now shown you how this is like this. X raised power n minus 1, phi n minus 1 y by x, plus so on, x square phi 2 y by x, then x phi y by x, plus some constant k equals 0. Now, what is the rule? Step 1. Put x equal to 1 and y equal to m, and get phi and m. Phi n minus 1m, phi n minus 2m, so on. You have to put x equal to 1, y equal to m, you will get phi n m. This will be an algebraic curve, equation of an algebraic equation, this will be an equation when equated to 0, equation, or a function of degree n. This will be a function of degree n minus 1, then n minus 2 of 2, degree 2 of degree 1, and so on. Okay, now how to find, this is a given. Why do we replace m equal to y, why do we replace y by m and x equal to 1? This is given on the book. You can see this is 2 line, because you okay, you will see it of your own. Now, how to find m? The m is obtained by putting phi and m equal to 0. So our phi and m equal to 0 gives us the slope. Gives us m, right? And c, how c is obtained? C is given by minus phi 2m by phi 3 dash m, or c is obtained by you need not solve this article, you can remember it. Still, if you are interested, you can see the article. If there is any problem, I can be of some help. C phi 3 dash m minus phi 2 m equals 0. This is same as this. C phi 3 dash and this. Or c square by factorial 2 phi 3 double phi. I am writing, why I am writing this. This is phi n, this is phi n minus 1. C square phi n minus 1 phi n minus 2 double dash c phi n minus 1 dash and phi n minus 2 equals 0. These either you have to take c from this equation, this is n and this is n minus 1. So this is n minus 1 and n minus 2. Okay, this is it. C phi n dash phi n minus 1. Actually, what do? I have written this x raised power n phi n y by x, algebraic equation x raised power n minus 1 phi n minus 1 y by x. We put y equal mx plus c in this, then separate the variables and separate the terms having degree n, having degree n minus 1 like this only, and we obtain these things, m and c. So I will be using only these things. To get value of m, I have to put phi n m equal to 0, and value of c can be obtained from this or from this. This is usually used when you have repeated roots. If you have repeated roots, use this. If you have non-repeated roots, use this. Okay, let me take up the questions. Let me write down the question. Say you have x cube 3x square y minus xy square minus 3y cube plus say x square minus 2xy minus 3y square plus 4x plus 5 equals 0. X cube plus 3x square y minus xy square minus 3y cube plus x square minus 2xy minus 3y square plus 4x plus 5. See, this is a cubic in x and y, wherein x cube and y cube are present, right? This is a cubic in x and y, wherein x cube and y cube are present. See, these are the equations, these are the terms whose degree is 3. These are the equations, terms whose degree is 2. This is the only term whose degree is 1, and this is constant, right? So I can write it in this form. Say x cube function of y by x square function of y by x, right? This can also be written in this form. I don't need that. Now what I have to write is that phi 3m. I have to find phi 3m, phi 2m, phi 1m, and so on. Phi 3m contains the terms whose contains the terms whose degree is 3. Its degree is 3, its degree is 3, degree is 3, degree is 3. But in this, what we do, we put x equal to 1 and y equal to m. When we first of all, is there any parallel asymptotes? No, because this is cubic in x and y, while in x cube and y cube are present. So there will be no asymptotes parallel to either axis. If x cube and y cube would have been absent, then we would have first seen what are the parallel asymptotes. There may be or may not have been. Okay. Now x cube and y cube are present, so there are no asymptotes parallel to either axis. So we have to go for the oblique asymptotes. So for oblique asymptotes, I have to find phi 3m, phi 2m, phi 1m, so on. Whatever I need to find are only these. Now phi 3m is what? Phi 3m is those terms whose degree is 3. In that we have to put x equal to 1, y equal to m. This is it. This is phi 3m. Now phi 2m, those whose degree is 2. So 1 minus 2m minus 3m square. Those terms whose degree is 2. Then phi 1m. There is only one term whose degree is 1. Its degree is 0. So it is 4x is 1. Okay, so it is 4 only. Now, how do I find m? To find m, this is the rule which I have told you. To find m, put phi 3m equal to 0, which gives us phi 3m. 1 minus 3m minus m square minus 3m cube equal to 0. Or 3m square, 3m cube plus m square plus 3m minus 1 equal to 0. Now, you can see m equal to minus 1 satisfies it. Does it? See, this is m. Wait. This is plus 3. Plus 1 plus 3. 1 plus 3m plus then this. This is minus 3 over here. Because this is 1 plus 3m minus m cube minus 3m cube minus m square 3m cube. Or 3m cube plus m square minus 3m plus 1. Right? You can see that m equal to 1 satisfies this equation. When m is 1, this is 3 minus 3, 1 minus 1, this is 0. Now use synthetic division. You know synthetic division. 3, coefficient is 1, minus 3 and minus 1. 1 into 3 is 3, 3 plus 1 is 4, 1 plus 4 is 4, 1 into 1 is 1. So differential equation. This will be 0 because this is the root of equation. Remainder will be 0. So differential equation is 3m square plus 4m plus 1 equal to 0. So what is m? Minus b plus minus under root of b squared is 16 minus 4ac 4 3 12 by 2a 2 3 6. So minus 3 plus minus 4, which is 2 by 6. So m is minus 3 plus 2. Okay? Oh, sorry. This is 4. This is minus b, minus 4. Minus b plus minus b square. 4 square is 16 minus 4 3 12. So it is again minus 4 plus 2. So minus 4 minus 2 is minus 6 by 6 is minus 1. Minus 4 plus 2, it is minus 2 by 6, so it is minus 1 by 3. So you have phi 3m, you have phi 3m found by putting x equal to 1 and y equal to, and in those terms wherein degree is 3. Putting phi 3m equal to 0, you have obtained m equal 1 minus n minus 1 by 3. See non-repeated roots. Now, what is phi 2m? What was phi 2m? We don't need that now. Phi 2m. In those terms, I have to put x equal to 1, y equal to m minus 3m square. This is phi 2m. You can have phi 1m also. Now what is C? You have non-repeated roots, so C is minus phi 2m, phi 3 dash m. Now minus phi 2m, it is minus times 1 minus 2m minus 3m square. Phi 3 dash, see this was your phi 3. 1 plus 3m minus m square minus 3m cube. This was phi 3m, right? It is dash means derivative. It is 3 minus 2m minus 9m square. Fine. Or you have 3m square plus 2m minus 1, 3 minus 2m minus 9m square. Now put C equal to 1, minus 1 and minus 3. Minus half of 3. When m is 1, what is C? When m is 1, 3 plus 2, 3 plus 2 minus 1 divided by 3 minus 2 minus 9. So 3 plus 5 plus is 4. 3 minus 11. It is 8 minus 8. So minus half. So what is the asymptote? Y equal mx plus c. Your m is what? 1. And your c is minus half. So this is an asymptote. This is a straight line, oblique asymptote. This is an oblique asymptote. When m is minus 1, what is c? M is minus 1. It is 3 into minus 1 square, it is 3. 2 into minus 1 is minus 2, minus 1. So 0 upon 3, minus minus plus 2, minus 9. So 0 by minus 4, it is 0. So the asymptote is y equal mx minus 1, x plus c. So y equal to minus x. You know this is an oblique asymptote. So this is first oblique asymptote, this is second. I have to find third when m is equal minus 1 by 3. So when m is equal to minus 1 by 3, what is c? 3 minus 1 by 3 whole square, 1 by 9, minus 2 by 3, minus 1. 3 minus minus plus 2 by 3, then 9 by 9 square, 1 by 3 square 9, it is minus 1. So it is 1 by 3 minus 2 by 3 minus 1, 3, 2 by 3 minus 1. LCM 1 minus 2 minus 3 upon 3. 9 plus 2 minus 1 by 3. So this is 1 minus 2 minus 3, it is minus 4. 9 plus 2, it is 10. So minus 2 by 5. So y is mx plus c. What's m? Minus 1 by 3x plus c is minus 2 by 5. So this is another straight line, an oblique one. So this is the method. Let me take one more question and then your asymptotes are finished. Let me have x square minus a square y square equals say x square minus 4a square. X square minus a square into y square equal x square into x square minus 4. Or you have x square y square minus a square y square equal x4 minus 4a square x square. Or you have x raised to power 4 minus x square y square. I have taken up this on this side, x raised to power 4 minus x square y square plus a square y square minus 4a square x square equals 0. Okay. x4 minus x square y square plus a square y square minus 4a square. Now, see, this is a fourth degree equation in x and y. Fourth degree equation in x and y, while x4 is present. So there will be no asymptotes parallel to x-axis. Thumb rule. Now, y4 is absent. So there may be an asymptote parallel to y-axis, which is obtained by equating coefficient of next higher power of y to 0. Now, coefficient of next higher power of y is y cube. Now, there is no y cube. So I have to come to the coefficient of y square. So I have to equate coefficient of y square to 0. You have coefficient of y square. This is y square. This is y square. Now, coefficient of y square. What is coefficient of y square? This is minus x square plus a square. Or x square minus a square equal to 0. Or x equal to plus minus a. So you have two asymptotes parallel to y-axis. X equal to a, x equal to a, x equal to minus a. These are two asymptotes parallel to y-axis. Fine. Two may be oblique. Let us find them. Now for oblique asymptotes, what you have to find? You have to. This is a 4th degree equation. You have to find phi 4, phi 3, phi 2, phi 1. Right? Let me come to that. See, these are the terms having 4th degree. x4, x square, y square. There is no cubic. This is 2nd degree. Phi 2, phi 2. Okay. Now, phi 4x, phi 4m, right. You have to take those terms while in x cube, you have to put x equal to 1 and y equal to m. In those terms whose degree is 4, right? This is 1, 4 and m square. Fine. Phi 3 m. There is no such term, so it is 0. Phi 2m. Phi 2m, it is minus a square, m square, minus 4a square. There is no first term, phi 1m, it is 0. Now, phi 4m, to find m, we need m. To find m, phi 4m, we have to put phi 4m equal to 0, which gives m square minus 1 equal to 0. M is equal to plus minus 1. So do different roots, 1 and minus 1. What is C then? C is minus phi 3m. Phi n minus 1m. Phi 3m. Phi 4n dash. So phi 4 dash m. So phi 3m is now nothing. Phi 4 dash. What is phi 4? This is phi 4. Its derivative is minus 2m. So when m is 1, C is 0. When m is minus 1, C is 0. So y is mx, y is x plus c, and y is minus x plus c. And you know y equal to x. This is y equal to x. This is y equal to minus x. Two oblique asymptotes. So there were two parallel asymptotes and two oblique asymptotes. This is quite simple. बिल्कुल बहुत आसान है. Now let me take up one more question, and because you may have repeated roots also. For that we have to use second option. Let me take up the question. X cube minus x square y minus xy square plus y cube minus 3x plus y plus 7 equal to 0. X cube minus x square y minus xy square plus y cube minus 3x plus y plus 7 equal to 0. Salik? Oh, this is an equation, huh? This is a cubic in x and y. While in x cube and y cube are present, so there will be no asymptote parallel to either axis. Now, we have phi 3m. 3, there is no phi 2m. There is phi 1m. Now, phi 3m is 1 minus m square plus m cube. You have to put x equal to 1 and y equal to m. Phi 2m is nothing there. Phi 2m 0. And phi 1m is minus 3 plus m. This is phi 1. Okay, now phi 3m equal to 0 in order to find m. Implies m cube minus m square minus m plus 1 equal to 0. M cube minus m square minus m plus 1 equals 0. Or you can have m square m minus 1 minus m minus 1 equal to 0. Or you can use synthetic division. M minus 1, you can take 1 only. M square minus 1 equals 0. So m is 1, 1 and minus 1. Repeated roots. So you have to use second one. Okay. For this is different roots. So for this you can, when m is minus 1, what is C? Minus phi 2m, phi 3 dash m. For repeated root only, you have to use that second equation. Minus phi 2m, you don't have phi 2m. Phi 3 dash, minus 1 minus 2m plus 3m square. So this is 0 when m is 1. When m is minus 1. When m is minus 1. Because this is 0, minus 1 plus 2 plus. So 0 by 4, which is 0. So this equation is y equal mx plus c. So y is minus x. This is an oblique asymptote, right? Quite simple. But you have now two repeated roots. Now to find when m is 1, c is obtained from, because you have repeated roots, c square by factorial 2, phi 2 double dash m, phi 3, phi 3 double dash m, then c phi 2m plus phi 1m equals 0, phi 2 dash phi 1m. Now, or c square by factorial 2, phi 3 double dash. See, first derivative is 3m square minus 2m minus 1. Second derivative is 6m minus 2. So it is 6m minus 2 plus c phi 2 dash. There is no phi 2, so it is derivative is 0 also, minus plus, what is phi 1m? m minus 3, 0. So we can find out. C, you can take 2 outside. It is c square 3m minus 1, then equal 3 minus m. Now your m is 1. C square 3 minus 1 is 2. 3 minus 1 is 2. So c square equal to 1. So c is plus minus 1. So what's m? Y is mx plus c. M is 1 in both cases. So it is x plus 1 and x plus minus 1. Because c is 1 and minus 1. M are same. So you have 3 oblique asymptotes, right? Okay. Shall we take, or this is okay. This is fine. This is the end of this. You have 2 or 3 methods to find for finding oblique asymptotes, but this method is sufficient. What actually you need to know the tool, how to find an asymptote. You know how to find parallel asymptote and how to find the oblique asymptote. Let me take one more example and say I have x cube minus xy square plus xy square plus x square minus xy plus 2 equals 0. X cube minus 2 x cube minus 2x square y plus xy square plus x square minus xy plus 2 equals 0. X cube minus 2xy x square y plus xy square plus x cube plus x square minus xy plus 2 equals 0. Okay, see, this is cubic in x and y, while x cube is present, so no asymptotes parallel to x-axis. Y cube is absent, so you can have asymptote parallel to y-axis, which is obtained by equating coefficient of y square to 0, and coefficient of y square is x equal to 0, which is asymptote parallel to y-axis. Okay? X equal to 0 is on what? Y-axis. So this is y-axis upon y-axis coincident. Okay, now I have to find phi 3m. 1 minus 2m plus m square. So it is m minus 1 whole square. Phi 2m. 1 minus m. Phi 1m is 0. Now what is, you have two repeated roots, 1 and 1. So I will write c square by factorial 2, phi 2 double dash. First is minus 2 plus 2m, second is twice m minus 1 plus c phi 2 dash m, which is minus 1 equals 0 plus phi 1m. So this is very simple. C square m minus 1 equal to c. Now what is m? I have m equal to 1. So c is twice m minus 1. I was in rush, c square minus twice. Oh, I have to write. This is only 2 because this is phi 3m. What is phi 3m? It is m minus 1 whole square. What is phi 3 dash? Twice m minus 1. What is phi 3 double dash? It is 2 only. So it is 2 only. 2 only. So c square minus c is equal to 0. C is 0 and 1. So what is m? mx plus c. 1x plus 0 and y equal to 1x plus 1. These are two oblique asymptotes. Now, this is all about asymptotes. I'll be taking a partial differentiation in my next lecture. Thank you.